Hi everyone, I'm Yasin. Mert. Today I and our group members Ebru, Mustafa and Çağrı present our final project. Project topic is about climate change. Climate change is among the biggest global threats in our world. Firstly, I will talk about temperature correlation between climate change. I used two datasets while creating my own work. You can easily access them on Kaggle. The first step is to analyze and forecast using time series, then data visualization to create a world map to interpret the temperature, and finally to calculate the temperature values in Ankara with the help of linear regression. Here, the temperature values are plotted. It has been observed that the temperature values tend to increase, especially after the 17th century. You can see that. After that, temperature changes were estimated with the help of time series. The blue values show the original values, while the orange value shows the predicted values. You can see that. A result quite close to the original was obtained. And then second data set using here. In this here, the temperature values are created according to the continents. Even in the European continent, where the temperature values are low, the temperature tends to increase. The highest temperature values were also found in African continents. You can see that African and European continents. And here we can see the countries with the highest temperature differences, highest to low. And then we can see the world map. Temperature increased by countries since 1840. Countries from the same continent are represented by the same colors, and you can use this button and access the years 1840 to 2013. And then countries are represented by circles. The size of circles is directly proportional to temperature differences. Maximum temperature values are arranged according to colors on the scale. And second section, in the section first, the temperature in Turkey was plotted, and then the temperature forecast for Ankara was made with the help of linear regression. You can see that's Turkey, 1950 to 2012. And then linear regression operation, and reaching higher temperature values close to the data obtained by the temperature estimation can also be associated with an increasing trend in temperature. And here you can see that test values and predicted values.
Hello, I am Mustafa, and I'll be talking about daily sea ice extent data and sea level change data. So this is a dataset that we use on our project. And the dataset has these attributes and values. I use pandas library to import dataset. From this data we can see there are independent maximum and minimum for northern and southern hemisphere datasets. Is it to be expected from the change of season? In addition to this, there is an average more sea ice in the southern hemisphere than the north. In this graph, we can see any average sea ice extent. As you can see, I used regression algorithm to predict extent data to 2095. This is the second dataset I used on our project, and it's about the changing sea levels around the world. And also I used pandas library to import dataset and made a graph which is showing us sea level from 1995 to 2015. And also I use regression algorithm to predict the sea level change by 100 years later.
As greenhouse gas emissions from human activities increase, they build up in the atmosphere and warm the climate, leading to many other changes around the world. In this atmosphere, on land and in the oceans, the dataset that we use for this climate change, greenhouse gas effects, we access this dataset from Kaggle. In this dataset, there are 11 columns and 308 rows. First column shows years between 1983 to 2008. Second column shows in which month fire occurred. From the third column to the 10th column, it shows the gas emissions, and the last column shows the difference in degrees Celsius between the average global temperature in that period and a reference value. We use this dataset to visualize the relationship between gas emissions and temperature change. The dataset has 8 different gases in it, so we want to use dimensionality reduction method for reducing the number of columns to 2. We scale the features in our data before applying PCA, so the volume has the standard deviation as 1 and mean as 0. Then we use other value in the data set, that is temperature column. We got such a graph. Our other topic was wildfire. Wildfire risk depends on a number of factors, including temperature, soil moisture, and the presence of tree and other potential fuel. All these factors have strong direct or indirect ties to climate variability and climate change. The dataset that we used for this federal firefighting cost data, we access this dataset from Kaggle as well. In this dataset, there are 6 columns and 35 rows. First column shows years between 1985 to 2020. Second column shows the number of fires in the specified years. Third column shows the amount of area burned in the fires that took place in the specified years. We use this dataset to see the amount of areas affected by forest fires by years, and we got the result as there has been a very high number of increase in the number of affected areas since 1985.
Life was difficult in the old. Nearly everything was done by muscle power. However, people were used to it, and the most important thing is they were not breathing poisons. Although technology has advanced rapidly since the Industrial Revolution, it has side effects on our world, and major disasters may be encountered if precautions are not taken. The graphic you see is the annual average of carbon dioxide gas in ppm since the Industrial Revolution. The data in the dataset we use is based on from a study named Yearly Average of Direct Observations from Mauna Loa and the South Pole at the University of California. As can be seen in the graph, there is a gradually increasing curve after the 18th century when the Industrial Revolution was active. When this curve is evaluated with the regression algorithm, we have seen that carbon dioxide emissions will increase to about 800 ppm in 2100. The increase in greenhouse gas emissions may result in some undesirable consequences, such as natural disasters, droughts, shifts in seasons, confusion in the migration times of animals, etc. That's why we need to take action as soon as possible.